Welcome to the first tutorial of ITE 2422 Database Management Systems. The tutorial 1 ER Diagrams. The learning outcomes of this tutorial. After completing this tutorial, you will learn about entities, attributes, relationships, and cardinality ratio from a real-world scenario and their specific notation in the ER diagram. Okay, let's move to the tutorial. This is the circumstance for which I will create an ER diagram. A hospital is the settings for this scenario. A database will be made to store information about patients in a hospital. On arrival, each patient's details such as name, address, telephone number are recorded. So you have to save the patient's details such as name, address, telephone numbers. So remember that when you are saving the address should be consist of 3 parts: number, street, and town. Those are the details should be saved for a patient. And they are given an admission number. After registration, they will be given an admission number for each patient for uniquely identification. They are then assigned to a particular ward. The ward can be accident and emergency, cardiology, oncology, etc. In each ward, there is a unique ward ID as well as maximum number of patients that can be admitted and number of doctors in this ward and number of nurses in a ward. Also, the details of the specific doctor who is in charge of the ward should be recorded. For each doctor, you must save their name, date of birth, and their national identity card number. For each nurse, the nurse name, address, and their contact number should be recorded. A patient will be treated by one doctor and several nurses throughout their stay. And each doctor and nurse may involve with several patients at any given time. As well as there is an assumption available. What is that assumption? A specific doctor and a specific nurse are assigned only to one ward and a patient visit only once to the hospital. Before drawing the ER diagram of this scenario, you must identify the entities, attributes, and the relationships separately according to this ER diagram. Okay, first of all, we go to the entities. Okay, what is meant by an entity? An entity is a self-contained thing. It is not required to perform any function. It only needs to be exist. An entity can be a single thing, a person, place, or an object in the database management. Such entities can have data saved about them. The entity relationship diagram is a design tool that enables database managers to visualize the relationships between the several entities. Let's try to identify the entities in this ER diagram. Remember that entities should be a noun, but all the nouns in this scenario is not entities. Let's read the scenario again one by one. A database will be made to store information about patients in a hospital. On arrival, each patient's details such as name, address, telephone number are recorded. That means you can identify, we have to save the information about the patient. So you can identify the patient is an object in this database management system. Therefore, we can call this patient as an entity in this ER diagram, in this scenario. So I highlight this one. So this is one entity in this scenario, patient. And you can see there are another nouns available. The patient details such as patient name, address, telephone number are recorded. So those are also nouns, but they are not entities. The thing is, the patient name is belong to the patient. The address also belong to the patient, and the telephone number also belong to the patient. Okay. Therefore, patient is an entity. The name, address, and telephone number we call as attribute of that entity. Okay, they are attribute of the patient entity. That means name, address, and the telephone numbers are attributes of the patient entity. And next you can identify, then they are assigned to a particular ward. Okay, the ward can be accident and emergency. That means it is the ward name, accident and emergency, or cardiology or oncology, or likewise there are several wards available. In the ward, there is a unique ward ID available. Okay, to uniquely identify a particular ward, there is a unique ward ID available, and the maximum number of patients that can be admitted. Assume that for a particular ward, only 30 number of patients can be admitted. So maximum capacity is then 30. And the number of doctors, how many doctors are available, and number of nurses, how many nurses in this ward. Okay. Also details of a specific doctor who is in charge of the particular ward. Okay, that means doctor in charge of that ward should be recorded. So here in this highlighted part is talking about another entity, that is we can call it as a ward. So from here to here it is mentioned about the details about a particular ward. Okay, you can identify a ward is another object, that means another entity. Okay, and here you can the details, that means unique ward ID, the maximum number of patients. The unique ward ID means that is belong to a particular ward. The maximum number of patients, that is also belong to a particular ward. A number of doctors, how many doctors available, that is belong to a particular ward. Nurses of a particular ward, that means how many nurses available. And also the details of the specific doctor in charge. Who is the doctor in charge? That is also belong to a particular ward. That means you can identify these other details are attributes of the ward entity. That means ward ID, maximum number of patients, number of doctors, number of nurses, they are belong to the ward. That means they are the attributes of a particular ward. And here you can identify for each doctor, the doctor's name, date of birth, and national identity card number should be recorded. Now here it is talking about another entity called doctor. Here, another entity doctor. So you have to save the information about the doctor. That means doctor's name, date of birth, national identity card number. That means doctor's name, NIC, and the date of birth are attribute of a particular doctor. Okay, that means you have to save the doctor as an entity in this ER diagram. And there is another one available. For each nurse, the nurse name, address, contact numbers should be recorded. So you have to identify the nurse name, address, and the contact number. So you can identify this nurse is another entity in this ER diagram, this scenario. Okay, for a particular nurse, you have to save the nurse name and the address of the nurse and their contact numbers. Okay, therefore you can identify nurse is an entity, name, address, contact numbers are attribute of the nurse entity. When you are reading this scenario, in the first sentence, it is talking about a database will be made to store information about patients in the hospital. Okay, sometimes you may erroneously identify hospital as an entity. The hospital also an entity. Remember that hospital is not an entity. There are several reasons that hospital is not an entity. Because the hospital is the complete system. Okay. Now, if you take hospital, think about how many hospitals available in this scenario. Okay, you can identify this one has only one hospital because we are going to draw an ER diagram for a particular hospital, only a one hospital. Okay, therefore we do not draw an entity for a one instance because there is only one hospital. For a one instance, we are not taking it as an entity. For the other entities, patients, you can identify there are more than one patients available in the scenario. Okay, if you get an hospital, there can be several patients, more than one patient. Okay, ward also, not only one ward, there can be several wards available. Okay, doctors also, there can be several doctors. Okay, nurse also, there can be several nurses. That if you take the patient, ward, doctor and nurse, there are several instances available. Several patients, several wards, several doctors and several nurses. But if you take hospital, there are no more than one hospital available. If you take the country, there can be several hospitals available in the country. But the scenario is talking about the particular hospital, one hospital. Okay, therefore, if you take this one as an entity, there is only one instance available. Okay, therefore, remember that if it has only one instance, we do not take it as an entity. Okay, because that is one reason. The second reason is this is the system. We do not take the system name as an entity. Keep that in your mind. Therefore, I remove this one. Okay, now we can identify there are 1, 2, 3, 4 entities are available. Okay, let's draw this ER diagram. Okay, first we will draw the patient entity. Remember that entities are denoted by a rectangle in an ER diagram. Therefore, I will use a rectangle. Okay, in the middle you can put the name of your entity. It is patient. Remember that when you are renaming when you are naming the entities, put it in singular format. That means patient, not patients. Okay, this is our patient entity. And there is another entity called ward. Therefore, I will create another one here. Ward. And you can see another entity, doctor. And there's another entity called nurse. Let's draw here. Okay, now we have drawn our 4 entities. Then we can draw the attributes of each entity. Okay, attributes mean they describe the entities. Attributes mean they describe the entities. For an example, if you take this patient, that patients describe that mean if you take the name, that name describe the patient. That means the name is belong to a particular patient. Address, telephone number. So those are attributes of the patient. Okay. Then the attributes are denoted by circle in the ER diagram. Okay. Let's draw a particular circle here. And here you can draw the name. And after that, you have to draw a line between circle and the patient. That means this name is belong to this patient. Therefore, you must draw a line. So I select a line. Remember that line you have to select without any arrow. You can use from here to here. Okay. That means this name is belong to this patient. And let's go to the next one, address. Another one, address. Name, address, after that telephone number. And you must draw an arrow, sorry, not the arrow, you must draw a line to each attribute. So usually in the ER diagram, this line should be straight line. Here there are curves available, therefore I select it should be this kind of line. So it should be this one. So here you can identify the address consists of 3 parts. That means number, street, and town. In such a situation, we call this address is a special attribute. That means there is a name for that one. We call this one as a composite attribute. Okay, that means this address is consist of 3 parts. Therefore, you need to separately draw another 3 circles indicating number, street, and town. Likewise here, number, and there's another one, street, and there's another one, town. Street, and after that, town. And after that, you have to draw this number is belong to this address, street also belong to this address, town also belong to this address. You have to draw it like this kind of a line. Here and again here and again here. After that, it's mentioned that and they are given an admission number. After the registration, that patient they will be given an admission number. So we can identify the admission number is a unique for each patient. Okay, that is also an attribute in this ER diagram. Admission number. Okay, we have to draw this line. And remember that the admission number, we can assume it is a unique. Therefore, for uniquely identification of each entity, we call it is a primary key. So if it is a primary key, you have to underline that attribute. So you can use this one as underline. Okay, let's go to the next entity called ward. Ward can be, the name of the ward can be accident and emergency, cardiology, oncology. That means, you know, there should be a name for a particular ward. Okay, that means accident, emergency, cardiology. Therefore, we can draw an attribute called name. Let's say ward name. In each ward there is a unique ward ID. Okay, unique ward ID. We can take this one as a primary key. Another attribute, ward ID. So we can underline that part. Ward ID, and the maximum number of patients can be admitted. Let's do another one. Let's say max patients. Maximum number of patients can be admitted. Number of doctors, nurses in the ward. So maximum patient is not the primary key. Okay. Then number of doctors. Number of doctors and number of nurses, number of nurses. Also the details of a specific doctor who is in charge of a particular ward. So you have to save the who is the in charge of the ward. That means doctor name. Okay, who is the doctor of the particular ward? Remember that is not an attribute. The ward, that means doctor's information. Who is the doctor? That doctor information is available in another entity. Therefore, who is the doctor in charge in the particular ward? You have to mention it in the relationship between doctor and the ward. Okay, I will come to that relationship later. Now I am going to draw only the attributes. Okay, now we have drawn the ward name, ward ID, max patients, number of doctors, and number of nurses. Let's draw the lines. Let's go to the doctor. In the doctor, you have to save doctor's name, date of birth, and national identity card number. So here we can draw doctor name, date of birth, and national identity card number. Let's say NIC. So you can take this national identity card number is a uniquely identification one. Okay, therefore we can put the NIC as the primary key for this entity. Okay, let's draw the lines. Then we can move to the nurse entity. For each nurse, the nurse name, address, contact number should be recorded. So we can go to the nurse name. Nurse name, address, and the contact numbers. Address, after that contact number. So do not underline those things. Okay, nurse name, address, and the contact number. And remember that for each entity, there should be a unique identifying attribute. Okay, here you know when you come to the patient, the admission number is the uniquely identification, primary key. For the ward ID is the primary key, unique identification of each ward. Here the unique identification of each doctor, the primary key is NIC. But the nurse, check that one. For each nurse, the nurse name, address, and the contact number should be recorded. Okay, but here we cannot identify a unique identification number. That means nurse name, the nurse name can be duplicated. The same name can be have for the more than one nurse. Address also can be same sometimes. The contact numbers also we cannot make it as a primary key. In such a situation, you have to generate the primary key. Therefore, I will draw another one. You can put the primary key as a nurse ID for uniquely identification. And so this is the primary key now, then you have to underline that one. Then after that, draw these lines. And here you have to identify an important thing in the nurse entity. For each nurse, the nurse name, address, and the contact number. So here address is a single attribute. Okay, when you come to the patient's address is consist of number, street, and town. It's mentioned that it is required. Then we draw it as an composite attribute. It is a composite attribute. Number, street, and town. But in the nurse entity, the address is enough as a single attribute. Therefore, we can put the address as a single attribute. And the next one is contact numbers. So here you can identify that's a plural word available, numbers. That means contact numbers mean this nurse entity may have, if you take a one instance of a particular nurse, may have more than one contact number. Okay, for an example, assume that there is a nurse called a particular nurse called A. A has more than one contact number. That means mobile number, home number, office number, or sometimes more two mobile numbers. Okay, that means this entity, if you take this contact number entity, it has more than one value. Okay, all other entities has only one value. That means if you take nurse name, it has only one name. Okay, address, only one address. Nurse ID, only one nurse ID. Likewise, if you take the ward, max patient, only one max patient. That means if you take a particular ward, see that 30 patient, only 30 max. Number of doctors and number of nurses, likewise. And here name, only one name available. Okay, but here in this nurse entity, it's mentioned as contact numbers. But when you come to the patient entity also, there is a telephone number. Okay, here you can see it is a telephone number. That means we are going to say only one number. Okay, therefore telephone number is a single attribute. But when you come to the here, it's mentioned as contact numbers. That means more than one numbers may be going to save in this attribute. Therefore, we call this attribute is a special attribute. We called it as multivalued attribute. Okay, multivalued attributes we have to denote in double circle lines. Okay, let's draw a double circle. This kind of double circle line. Two lines should be there. That which means contact number is a multivalued attribute. Okay, now let's move to the relationships. Okay, so relationships mean if you take these attributes, there are relationships between these, not the attributes, entities. There can be relationships between these entities. Read the scenario again. A database will be made to store information about patients in the hospital. On arrival, each patient details such as name, address, and telephone number are recorded where possible. And they are given an admission number. After that, they are then assigned to a particular ward. That means if you take a particular instance of patient, if you take a one patient, that patient may be, patient should assign to a particular ward. Okay, so you can identify assign. So it is the relationship patient assigned to a ward. The relationships we can identify using the verbs. Okay, then they are given admission number, then they are assigned. So we can take this assign is a relationship. Remember that relationships are denoted by a diamond sign in this ER diagram. So you can go to the diamond sign, this kind of one, and the patient and the ward in the middle you can draw this kind of one, and you can use assign. And after that we have to use these lines with this relationship. Likewise, patient assigned to a ward. And here you can identify in each ward there is a unique ward ID and the maximum number of patients that can be admitted, and as well as number of doctors and nurses of a particular ward. Number of doctors, that means if you take a particular ward there can be many doctors available, as well as if you take a particular ward there can be many nurses available. Okay, therefore that means we have to identify who is the, now that we can identify that here is the number of doctors and nurses available. Assume that if you take a particular ward, let's say cardiology ward, there are seven doctors and 20 nurses available. Okay, then here information only the number is available, but we don't know who are the 7 doctors, what are the names and what are the information of the 7 doctors and what are the information of the 20 nurses. They are available in doctor and the nurses. Okay, therefore to identify that one separately, you have to draw a relationship between ward and the doctor as well as ward and the nurse. Okay, let's draw the relationship. Let's say here a particular doctor assigned to a particular ward. Let's say assigned to, or whatever the name you like, suitable name, assigned to a ward, and draw this kind of relationship, this kind of line. As well as there is another one, again assigned to ward assigned to a nurse, doctor assigned to a ward, nurse assigned to a ward. Okay, now when you are drawing this relationship, the ward and the doctor, that doctor assigned to a particular ward, we can get the information who are the doctors assigned to that ward. That means assume that there are number of doctors, 7 doctors. Who are the 7 doctors are available can be calculated by this relationship. Okay, in relationship include who are the 7 doctors. For an example, 7 doctors. Who are the 7 doctors available in this relationship? Okay, then this number of doctors can be calculated by this relationship. Okay, that means this 7 information, that there are several doctors available, that 7 information is available in this relationship. Okay, therefore now the 2 places you have the number of doctors, that here also number of doctors available. From this relationship also you can calculate how many doctors available. In such a situation, this attribute we call it as a derived attribute. That means how many doctors are available can be calculated by this assigned to relationship. Okay, therefore we call this one as a derived attribute. Okay, if it is a derived attribute, you can denote it in the 2 ways. One way is do not draw this attribute, just erase this attribute. Or otherwise, if it is a derived attribute, you can represent it using the dotted or dashed line. Likewise, here you can see this kind of a dash line. Okay, now that, which means this is a derived attribute. Derived means it can be calculated by here. The same thing here, number of nurses. Okay, the number of nurses can be calculated by this assigned to relationship. Okay, in this assigned to relationship has who are the nurses assigned to this ward. Assume that there are 20 nurses available. Those information of 20 nurses are available in this assigned to relationship. Therefore, here this attribute value can be calculated by this relationship. Therefore, this attribute also will become a derived attribute. Okay, what you can do? Two things, just erase this attribute or denoted it by a dotted line. Likewise, this kind of dotted or dash line. They are derived attributes. Okay, now you have learned there are special attributes. One attribute is composite attribute. If you take an address is consist of number, street and town. But this address is not a composite. It is a single attribute. But this attribute is a special attribute, composite attribute. It has 3 parts. Okay, and another attribute called multivalued attribute. Example is contact number. That means here we have more than one contact numbers for a particular nurse. Therefore, we call this one as a multivalued attribute. And there is another special attribute we call derived attribute. We have 2 derived attributes denoted by dash line. Derived attribute means the value of these attributes are calculated by another attribute or another relationship. Okay, it's no need to be a relationship. Sometimes this number of doctors, assume that this number of doctors can be calculated by this max patient. If it is calculated by the max patient, however, from the max patient you cannot calculate it here. Assume that we can calculate the number of doctors by using the max patient, then the number of doctors is a derived attribute. Okay. For an example, you can use another. Assume that there is an attribute called age to this doctor. There is an attribute called age. What is the age? Okay. That means age is 27 or 30 or whatever the one. But we have the date of birth. If you have the date of birth, you know age can be calculated. If you know the date of birth, you know what is the age of the particular doctor. Therefore, if we need to save the age also, age can be calculated by the date of birth. Therefore, age also become a derived attribute. That means it can be calculated by another attribute. Another attribute or another relationship or whatever the way, if that value of the attribute can be calculated, we called it is a derived attribute. Okay, let's move to the next one. Okay, next here you can identify a patient will be treated by one doctor and several nurses throughout their stay. Okay, if you take a particular ward, you know there are several doctors available, but the patient can be treated by a particular one doctor and several nurses. So you have to identify if it is a patient, who is the doctor treated by. Okay, therefore you can identify there should be a relationship between patient and the doctor. The patient treated by a particular doctor. So we can draw it using this relationship. Not this kind of dotted line. This kind of one, we can put it as treated by. So draw the lines. Okay, patient is treated by a particular doctor, as well as patient can be treated by several nurses. There is another relationship between patient and the nurse. So we can draw it likewise. Treated by treated by nurse. And there is another one I forgot to mention in the ward entity. So here we can identify they are then assigned to a particular ward. Ward can be accident, emergency, this kind of one. In each ward, there is a unique ward ID, maximum number of patients that can be admitted, number of doctors, nurses in a particular ward. That number of doctors can be calculated by using this assigned to, and the number of nurses can be calculated by using this assigned to. Also, the details of a specific doctor who is in charge of the particular ward should be recorded. Okay, that means there can be several doctors assigned to this ward, but there is a one doctor available who is the in charge. Okay, we have to draw that one. That means there is another relationship with the doctor. That means there is an in charge. Okay, we can draw it likewise. Relationship, let's say doctor in charge. Doctor in charge, it should be from the doctor entity and the ward entity. Okay, next we have to draw the cardinality ratio of this ER diagram. Okay, what does it mean by cardinality? Cardinality defines the possible number of occurrences in one entity which is associated with the number of occurrences in another entity. For an example, if you take a patient assigned to a particular ward, that means if you take a one patient will be assigned to only to a one ward. Okay, if you take a one ward, there can be many patients. Okay, therefore we call this cardinality ratio is here ward side is 1, the patient side is many. Okay, there are several notations available in the ER diagram. We can denote it using the ER diagram using several notation. Here I use the Chen notation. That means we use 1 and M, that letters in this ER diagram. How to do this one? Here you can use 1, and this side is many. Okay, we call this one is many to one relationship. So what is the meaning of this one? If you take one patient is assigned to only a one ward. Here one means assigned to only a one ward. Okay, that means you may think that at a particular instance only a particular one ward. If the patient arrived another day, that patient may be involved to another ward. That means there can be 2 or 3 wards. Okay, but in the assumption it is mentioned that a specific doctor and the specific nurses are assigned only to a one ward, and a patient visit only once to a hospital. Okay, that means once if you come to the hospital, you assign to only for a one ward. Therefore, we use this cardinality ratio here as 1. And the other side is many. How it is many? Take this ward as 1. Okay, if you take this ward as 1, how many patients can be there? That means 1 or many. Okay, there can be many patients, not only one patient, there can be possible list many. In such a situation, we put it as many. Okay, likewise, we have to draw the other cardinalities of the ER diagram. Okay, let's go to the assigned to. Okay, word assigned to a doctor, and the word doctor in charge to a particular, if you take the doctor, that doctor is in charge to a particular ward. Okay, now take this in charge part. So when you're taking when you are going to draw the cardinality ratio, let's say we draw the cardinality ratio for the ward side. Okay, if you put the cardinality ratio to the ward side, take the doctor as 1. Okay, if you take one doctor, he is in charge of how many wards? Okay, sometimes how many in charges are available, it is in the scenario. If it is not in the scenario, you can see the general situation. If it is a particular doctor, usually doctor is in charge of one ward. Okay, that means if you take a particular doctor that is in charge of the cardiology ward, okay, only a one ward. So therefore we can say doctor in charge in the one ward. Therefore I will put this one as 1. And put the cardinality ratio to the other side. Take one ward. If you take one ward, how many doctor in charges are available? How many doctors are in charge? Okay, so usually there should be only one doctor in charge. Okay, so it is mentioned in the scenario also. When you come to the ward, in each ward there can be unique ward ID, maximum number of patients that can be admitted, and number of doctors, number of nurses on the ward. Also, details of a specific doctor who is in charge. Details of a specific doctor. Details of that means only one doctor available. Okay. Therefore, if you take particular one ward, there is only one doctor available. Okay. Therefore, in such a situation, this side also mentioned as 1 cardinality. Now it is mentioned as 1-to-1 relationship. That means if you take particular one doctor, he is in charge of only a one ward. As well as if you take a one ward, there is only one doctor in charge available. Okay. So likewise, go to the assigned to. That means here, there are, if you take a particular ward, there are number of doctors, number of nurses available. That means number of doctors. Okay. Take the doctor side. Okay. If you take the doctor side means here. Now when you are going to draw the cardinality for the doctor side, remember that take the other side as 1. That means ward. Take the one ward. If you take one ward, how many doctors are assigned? Okay. Here it is mentioned that number of doctors. That means there can be several doctors, not only one. That means there can be many doctors. Okay. If you take a particular ward, there can be many doctors. Therefore, you can draw it likewise. Here, many. There can be many doctors. And take the cardinality to the other side, ward side. Then again, you have to do the previous one. That means take the doctor side as 1. Okay. If you take one doctor, he is assigned to how many wards? That means he is working on one ward or many wards. Okay, you can take it from the scenario. in this scenario, you can identify there is an assumption. A specific doctor and specific nurse are assigned only to a one ward. Okay, that means if you take a one doctor, he is assigned only to a one ward. Therefore, cardinality ratio of the other side is 1. Here is 1. Now you can identify this is many to one relationship or one to many relationship. Okay, let's go to the assigned to. That means nurse and the ward, the same relationship, likewise the doctor and the ward. Okay, if you take one ward, how many nurses are available? Okay, you know there are number of doctors and nurses in the ward. That means if you take one ward, there can be many nurses. So put here as many. So remember that always when you are going to do the cardinality to the nurse side, take the ward as 1. One ward, there can be many nurses. Okay. One word means do not take the one from here. That means here 1, 1, 1. Do not take this one. Always this is 1. Okay. One word, there can be many nurses. Now put the cardinality ratio for the ward side. Then what you have to do, take the nurse side as 1. Okay. Now take one nurse can be assigned to how many wards? It is mentioned that a specific doctor and a specific nurse are assigned only one, so only to one ward. That means if you take a particular nurse, that nurse is assigned to work or assigned to a works in one ward. Therefore, we can draw the cardinality here also as 1. Now this one also one to many relationship. And go to the patient and the nurse, there is also a relationship. And the patient and the treated by, there is also a relationship. Put the cardinality to these two one. First of all, take the patient treated by a doctor. Okay. Now take the put the cardinality to the doctor side. So if you want to put the cardinality to the doctor side, you have to take the patient as 1. Okay. Take one patient. If you take one patient is treated by how many doctors? Go to the scenario. Here you can see in the scenario, a patient will be treated by one doctor and several nurses. Okay. If you take the doctor, one patient will be treated by only one doctor. Okay, that means if you take one patient is treated by only one doctor. Therefore, cardinality for this find is 1. Okay, now put the cardinality to the patient side. Okay, if you want to put the cardinality to the patient side, you have to put the doctor as 1. Okay, take one doctor. If you take one doctor, is treated to how many patients? Okay, is that only one? That means if you take a particular doctor, is treated to only one or many. Now you have to think that sometimes those information not available in the scenario. Then you have to take it in the usual way. So if you take only particular one doctor, usually doctor can be treated to many patients. But if you take one patient, there is only one doctor available. Okay, if you take one doctor, there can be many patients. So what you can do is, here you can use the many. Okay, one doctor treated to the many patient. If you take one patient is treated by only one doctor. Here also many to one relationship available. And go to this one, patient treated by nurse. If you take one patient treated by how many nurse? Okay, that means we are going to add the cardinality to the nurse side. Okay, if you want to add the cardinality to the nurse side, you have to take this patient as 1. Okay, if you take one patient is treated by how many nurses? It is available. A patient will be treated by one doctor and several nurses. That means there can be more than one nurse available. Therefore, this side is many. And put the cardinality to the other side. Okay, that means patient side. If you want to put the cardinality ratio to the patient side, you have to take the nurse side as 1. Okay, take one nurse. If you take one nurse, can be one nurse treated to how many patients? Okay, now here it is, you can see the patient will be treated by one doctor. Okay, a patient will be treated by one doctor and several nurses throughout the stay, and each doctor and nurse may involve with several patients. Okay, that is why we put the many to here also. That means each doctor is involved in many patients. In the general scenario also it is many. In the scenario also it is mentioned that, sorry, in the general situation also it is many. In the scenario also it is mentioned as each doctor and nurse may be involved with several patients. If you take one doctor, involved in many patients. Likewise here, if you take one nurse, will be involved with many patients. That means treated to many patients. Therefore, here also many. Okay, and here many to many relationship. And remember that. So here also M, here also M. We do not use the same letter in the Chen notation. Okay. Therefore, we use the next alphabet letter. That means after the M, the next alphabet letter is N. Therefore, here we use the N. Remember that N also, that meaning is many. So whatever the alphabet letter you use here, that means the meaning of that one is many. Okay. Therefore, here relationship is many to many. Another thing that you might be wondering that this number of doctors is a derived attribute. This number of nurses also derived attribute, but the max patient is not a derived attribute. So what is the reason? The reason I already explained. The number of doctors can be calculated from this assigned to relationship. In the assigned to relationship, you know, in a particular ward, what are the doctors available? Assume that there are a particular ward, there are 10 doctors. The information of 10 doctors is available in this relationship. Therefore, you can calculate the total is 10. Okay, that is why this is derived. And the number of nurses, it can be calculated from this assigned to, ward assigned to nurse. Okay, that how many nurses are working that word can be calculated from here. That is why this attribute is not necessary. These two attributes are not necessary because they can be calculated. You can get the information, but the max patient cannot be calculated. The reason is, I will explain using an example. Let's say this is a word. Okay, assume that this is a ward, and this ward has let's say maximum patients. Let's say max patients equal 10. We can allocate this ward max 10 patients. That means there are 10 beds available. So let's draw the beds 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Okay, there are 10 beds available, then therefore you can allocate maximum 10 patients. Assume that currently occupied patients equal 7. Currently 7 patients are occupied. Assume that these are the occupied beds. Patients 1, 2, 3, 4, 5, 6, and 7. Okay, currently 7 beds are occupied. That means there are 7 patients are available. Okay, that there are 3 remaining beds available. Then that means another 3 patients can be assigned to this ward. Therefore, remaining is 3. Okay, how did you calculate 3? 10 minus 7. Okay, that means this is 10 minus 7. Okay, that when you come to these relationships with the ward and the assigned patient, we can calculate this 7 from this relationship. I will use another color. From this relationship, we can calculate there are 7 patients assigned to that ward. The 7 patients. Okay. But the maximum number of patients, it is not there, because the maximum number of patients can be vary from ward to ward. Assume that a cardiology ward, there is a 10 maximum patient. At oncology, 50 patients. And there is another ward, 30 patients, maximum patients. Likewise, it can be varied. Therefore, you have to save this information, because you cannot calculate it from anywhere else. But the occupied list can be calculated. Okay, assume that you need to save the occupied and the remaining also. You need to save the occupied and the remaining as those information in the ward also. Then you can draw another attribute, occupied. How many patients currently occupied? And another one, another attribute, remaining. How many beds remain? Okay, in this situation also, occupied, we know occupied is 7. Okay, this 7 is already there. We can calculate it from this assigned relationship. How many patients are assigned? That means this occupied can be calculated. Okay, but the max patients cannot be calculated. You have to save. Max patient is 10 here. Max patient is 10, but the occupied is 7. It is no need to save that one. It is already there. We can get it from here. The data is already there. Therefore, this occupied is a derived attribute. We can get the information from somewhere else. Therefore, what you can do is, you can draw this one as a derived attribute. Likewise, that means dash line. Likewise, this is a derived attribute. As well as remaining. Okay, remaining is 3. Remaining is 3. 3 also can be calculated. Not directly, but indirectly you can calculate it, because you have the max patient. You have the how many patients currently occupied. 10 and 7 is available. You can calculate this 3 by 10 minus 7. That means this data is already available in 2 different places. You have to calculate and get. However, you can get that one. Directly or by calculating, you can get this one. Therefore, remain also you can calculate it. The data is already there. That is why here this is also a derived attribute. So what you can do, you can draw this one as a dash line. Okay. However, that occupied and the remaining are not mentioned in the scenario, as in that we need to save this information. In such a situation also, they are derived because that can be calculated. But the max patients cannot be calculated. You have to store it in the database in this attribute. That is why this is the usual, that normal attribute, the max patient 10. But the other things can be calculated, then they are derived. I think you may understand what does it mean by derived and other attributes. Okay. Likewise, the number of doctors. How many number of doctors can be calculated from this assigned? That means 5 or 10 or how many numbers. And how many nurses available can be calculated from here. Number of nurses. That is why those things are derived. Okay. That means you can directly get from here. Number of doctors you can directly get from here. Occupied you can directly get it from here. The remaining you cannot directly get, but you can get it from here and here. 10 minus 7. You have to get the 10, you have to get the 7 and do the minus. Deduct the 10 and 7 and get the 3. However, you can calculate it, therefore it is a derived attribute. That is why these number of doctors and number of nurses are derived. Max patients is not a derived attribute. Okay. I think you may understand this part. And this is the ER diagram for this scenario. And this is the end of the tutorial 1. Thank you.